Let's take a look at this, the most ridiculous demo ever. I really am going to be honest with you, it is highly annoying, but that's why you're here to see me. Okay, so to start off with, I am going to create a new file here, and I'm going to call it band.exs, because this is going to be the little band that I'm going to pull together of singers. And they're going to sing to us. And so because I'm the world's worst typer, as you could tell right there, I have a little snippet in here, and this is some Elixir code that I'll walk you through really quickly. The very top right here is what's called a module attribute. It looks just like Ruby to a lot of eyes. Jose would jump up and down and say, it's not like Ruby. But this is essentially, you can think of it as a module level variable. We'll just think of it for now. I have one public method right here that is running an enum.map. This is an enumerator module, and it's running map, just like you'd see in JavaScript. Map just basically takes a chunk of data and brings back select parts that you want. This is called a range. So if I do 1.20, that is the range of numbers from 1 to 20. I'm going to iterate 1 to 20. This is a callback. It's an anonymous function. You can think of it just like a callback. Fn instead of function, n is the argument, and this is basically saying here comes anonymous function. I'm using enum.random to pick out a random voice, and then I'm piping this out to system.command. You get the idea. If I do this right, you'll hear NDC London 20 times in a row. So let's do this. So to run this, I'm going to use IEX, Interactive Elixir. This is another tool that comes. It's just the Elixir REPL. I'm going to pass it the band.exs file. There we go. And here I'm going to say band.sing. That's not working, and it's scaring me. Okay, then. Would you believe? Because I didn't save the file. I was going to say, Rob, your demo is just awesome. Okay. We know it works. We know it works. Okay, thank you for that. We know it works. My challenge now is I want to start flexing some of the OTP power that is built in, meaning I want the voices to sing all together at once, concurrently. So there's a number of ways I can do this. The first thing I can do is I can just create another method here, and I can call this sing together. See, I told you I'm a really bad typer. And what I can do is I can use the spawn keyword, and this is kind of the gently opening door to the asynchronous world that's at your fingertips. Spawn just creates another process. You give it some code, and out it goes into its own little process that is a child of your running process. So whenever I run this file, I'm running in a parent process, and then if I spawn another one, I have another process that runs in it. This is coding in Elixir. You code processes that talk to processes. That's how it's done. So I can do this, and I can say, use the band module, this current module, use sing, and then that's it. No arguments in here. So now that I have sing together, I can load this up again, and I can say band.sing together. So we have a problem. Can you guess what the problem is other than asynchronous programming? The problem is that I'm spawning one process, and I'm giving it 20 things to do. So of course, it's going to do what I tell it to do, but it's sitting in another process doing it. I wanted to point that out to you because that is something that stalls a lot of people that are unaware of these things when they first start using Elixir, like me. So what we want to do instead of this is we want to actually work in a concurrent way. And if you start thinking about processes and coding one process talking to another, your head can kind of explode like, how can I actually put all this together? Well, the good news is OTP has done this for you. These guys have had 20 plus years to work this thing out. So what they have come up with is the GenServer. This is one of like a mountain of things that are available to you. There's agents, there's tasks, there's supervisors, there's all these things that allow you to code one process to talk to another. GenServer looks a little tricky. What it is it's a protocol, if you want to call it that, for services talking to other services. You have callbacks that you can override in there. There's a number of them. There's 7 of them that you can actually override. The one that we care about is this one right here, handle cast. Its brother or sister is handle call. Handle call is synchronous. So if you want to talk to a service and have it do some computation and wait for the answer to come back, you implement handle call. If you want, like we want right now, to do it asynchronously, use handle cast. So that is the internal workings of a GenServer. You don't inflict that upon other people, however. You tend to wrap that kind of stuff in a public API. So right here, I'm saying, hey, start up a service for me, start up a process, and give me a link to you. That's what this is, and you'll see this in a second. The second one is the one public method I have, which is sing it. And then we have to pass it the process ID. So there's a process running around in memory in the VM somewhere. And when we call into Singer, we're going to say, use that process and send it this data. And underneath the hood, we use genserver.cast. It basically means do the asynchronous call, and I don't care what happens. Okay. So we have this, and now let's rewrite our code right here to actually use this. And I'll talk about what I'm doing here in just a second. And this is going to be Singer, and start link. There we go. And singer.startLink, and then down here we are going to just say singer.singit. And we're going to pass in the PID and the voice. Okay, this right here is called pattern matching. If you have never seen this in Elixir or other programming languages, I'm going to talk more about what this is, but basically what you're doing is you're matching a structure on the left to the structure on the right. This is how you do variable assignment in Elixir. I'm going to talk more about this in a bit. In fact, I'm going to go off on it. Then what I'm doing is now that I have this Singer process kicked up in my little GenServer, I'm just going to tell it to sing asynchronously. Okay, so I should be able to come in here and reload this. And what do you guys think is going to happen? Anybody have a guess? You think so? Let's see. NDC London. No. Again, asynchronous programming. Woohoo! The difference we have back here, though, is it did indeed happen asynchronously. It did not happen concurrently. And this is the kind of mindset you start getting into, and this is one of the processes that literally broke my brain as I'm trying to figure out what's going on, and I'm like, oh, God, concurrent programming. The fun part is you actually get used to this. The sad part is getting used to it. What is happening back here is I have one process, again, doing 20 things. I want 20 processes to do one thing. Does anybody have a guess as how I can do that? Just looking at this code. Shout it out. That's right. Move it inside the loop. All right. Anybody think this is going to work? All right, let's see. If I say band.sing. Sorry. Told you it was an annoying demo. All right. That worked, but that was a cacophony. That sounded horrible. Let's actually change this now to do cellos. So all one voice. The reason I want to do it this way is because I want to show you by listening by ear that it is happening at the same time. So let's do band.sing. That's 20 voices at once, same time. We did it. That's very exciting. Sort of. Okay, I know you guys are mad at me. All right, so let's now move into doing something a little bit more complicated, because you never actually do one or the other. You don't actually do things serially, and you don't do things all at once. Typically what you're going to do is you're going to have a bunch of workers that might then spawn more processes. So we can actually do this, and for this I'm going to do my conductor. Right here I have a conductor, and my conductor is going to be in charge of 5 voices, groups of 5 voices. I want to have 3 groups of 5 voices singing at the same time. So for that, let's see what kind of code it takes to do that. And here I'm just going to say groups, and then the first thing I'm going to do is I'm going to set voice equal to a case statement, and then let's see, sorry, I'm totally missing something here. enum.map, and then I'm going to do 1 to 3, there we go, and then n, and then I'm going to set the voice equal to a case statement, and then a case n. And so basically all I'm doing right here is obviously a case statement deciding which group is going to sing. Now what I need to do is I need to have the 3 asynchronous groups sing things concurrently. Does anybody have a guess how I do that? With code you've already seen. Anyone guess? All right. Spawn, band, conductor, And then this time I'm going to pass in the voice that I want it to sing. The conductor is going to spin up a single service for 5 individual singers, right? And it's going to launch that. Now, how do we actually know it's going to do it? Let's go down here, and I'm going to put io.puts singing with, and then we have one lovely little thing, string interpolation with Elixir. I like it. Okay, so now let's make sure that this works, and I am going to do band.sing. NDC London. Oops, did I blow it? Oh, I do band.groups. I'm sorry. Band.groups. NDC London. I know, it's so bad. But the fun thing is, you can see by the output here, cellos, cellos, cellos. I have 5 cellos, I have 5 pipe organs, and I have 5 good news. So what I've just created here, and this is kind of the end of this silly demo, what I've just created here is a worker. That worker has spawned more processes. This is kind of the feeling that you get when working with OTP. A ridiculous example, but let your mind wander on the orchestration that you can have now with concurrent programming at your fingertips in all of 46 lines of code, which I know is ridiculous, and I hate saying, oh, 46 lines of code. But it's true. I mean, it's true. And this is just the nature of programming. Okay, I want to do one more, actually, because you asked about the timing on this. And I also want to show one other feature, which is recursive programming. So I'm going to do the voices in a staggered way. And here I'm going to start out by saying enum toList, and this is going to take a range, and it's going to pipe that range. Actually, I need to do it this way. And it's going to pipe the range, darn it, into itself. That looks weird, doesn't it? So what's actually happening here is I'm using enum toList. All it's doing is taking that range right there, and it's turning it into an array of integers. I'm going to loop over that. Actually, I'm not going to loop over that. I'm going to pass it into another function. That next function here is this guy, staggered. And then I'm just going to pass in the list. And then what it's going to do is it's going to iterate over everything, and I actually have to have what's called an exit function. And this is going to take in an empty list, and I am going to put io.puts all done. Okay. What we're using here is more pattern matching. When you call a function in Elixir, Elixir is going to try and match the argument to the function call. If it matches, it'll get executed. So what I'm doing up here is I'm piping the result right here using the amazing pipe operator. The pipe operator just says take the result of the first function on the left, pipe that result into what's coming on the right. If you use Linux, you know the pipe operator. And so that means that I'm going to call staggered with what's called an arity of 1 argument coming in. What can I do with this list? Well, I can loop over the list. I can do all kinds of things. But what you see Elixirists do is they match on a very particular structure for this list. This is a broken down list. This is actually splitting that list into a head and a tail. I put list there. I should say tail. I'm sorry. So you can think of it like a centipede. We have a 20-piece centipede. We have a centipede with a head, and then we have 2 to 20 pieces left. Elixir will match on this, and it'll split that list for you so you can have the first item and then the remaining items right here. So what I can do with this is I can now kick up my service, and I could say, okay, PID equals singer, start link. There we go. And now that I have this, I'm going to say singer.sing, and then I'm going to pass in the PID, and then I'm just going to tell it to do the cello. Darn it, why do I do that? Now that I've done that, I am going to use the timer again. Have I done this yet? I haven't done timer, no. Timer is an Erlang function, so you can dip into Erlang anytime you want, because it's always there. You can just use the little colon notation right here, or colon, as John Skeet says. Okay, I'm going to set it to sleep, and then, can you guess what the last line is going to be? Anyone? Staggered. Yes, staggered. And this time, however, I'm going to pass in the tail. And so what this is going to do is it's going to pass the tail up, and then the tail is going to be separated into another head and tail. And so then I have 2, and then I have 3 through 20, 3 through 20, blah, 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 blah. You get the point. All right. So what do you think this is going to sound like? Band.exs. And then we're going to say band, bad Rob, band.staggered. Darn it. I almost had it. Singer.sing it. Okay. And then we say band.staggered. You guys feeling the groove? This is the worst demo I've ever done. I'm sorry to inflict that on you.